Hi, this is Prakash from 60 seconds. Today we'll look at an algebra problem from CAT 2008, considered to be a difficult problem in the environment of exam. We'll see how we can solve this using a conventional approach and again using options smartly. So let us proceed. So please go through the question and have a look at the options and try it on your own. Once you've tried enough, then please look ahead for the solution. Okay. Assuming that you have tried the question, let's look at the solution. So I'm assuming let the numbers be n minus 1, n and n plus 1. So my first number is n minus 1, second number is n, third number is n plus 1. Actually it doesn't matter what the numbers are. It can be n, n plus 1 and n plus 2. It really doesn't matter. But just for our convenience we have taken n minus 1, n and n plus 1. So you will see the benefit in a short while. Why am I taking the first number to be n minus 1 and not n? But even if you take n to be the first number, then your next two numbers will be n plus 1 and n plus 2, and it will not make a difference to your answer. Okay? So let the numbers be n minus 1, n and n plus 1. So as per the question, if I raise n minus 1 to the power of 1 and n, second number, to the power of 2 and n plus 1, the third number, to the power of 3, and I take the sum of all three, then the number obtained, if I take the square root of that, that will be equal to nothing but the sum of the three original numbers. If I take the sum of the three original numbers, it is nothing but n minus 1 plus n plus n plus 1. So I know this 1 and 1 will get cancelled and I will get 3n. It is nothing but the sum of these three numbers. So it will give me nothing but 3n. So when I take the sum of these three on the LHS and if I take the square root of that, that equals to 3n. So instead of that, what I have done, I have taken the sum and I have squared it and I have equated to my LHS. I hope this part is clear. So this is the tricky part, or this is the difficult part, that is framing the equation. Once you do this, then the rest of the question is easy. Okay, so let's see how we can solve this. So solving the above equation we get, so this n minus 1 comes out as n minus 1, n square is nothing but n square, n plus 1 whole cube. I know n plus 1 whole cube, a plus b whole cube is nothing but a cube plus b cube plus 3a square b plus 3ab square. So I have n cube plus 3n square plus 3n plus 1, that is what we get. And square of 3n is nothing but 9n square. So that's what we get when we try to simplify this equation. Now this minus 1 and this plus 1 will get cancelled, right? And I have this 3n and I have a n here. So 3n and n will add up to 4n. And I have n square and 3n square, which will give me 4n square. And when this 9n square comes to the left hand side, it becomes minus 9n square. So effectively it will give me 4n square minus 9n square, which will give me 5n square. So that's what we get. So this n cube comes at n cube, n square plus 3n square is 4n square, minus 9n square will give me minus 5n square plus 4n. So I can easily see that. So I can clearly see that I can take n common. So I effectively get n square minus 5n plus 4. Now this is a quadratic equation. Factorizing, I get n minus 4 into n minus 1. So either n equals 4 or n equals 1. Now I know that n cannot be equal to 1, because if n is equal to 1, n is my second number. So my first number comes out to be n minus 1, and n minus 1 in that case becomes 0. But I know all my three integers are positive integers. So the first number cannot be 0, because 0 is not a positive integer. So this violates the premise given in the question that all the integers are positive. That's why n cannot be equal to 1. Thus n has to be equal to 4. Okay, I hope it is clear till here. So the three positive integers will be 3, 4 and 5. And thus our answer is option number 1, which is my numbers like my first number. The question is asked, what is my first number? It says the minimum. So the first number, which is nothing but 3, which lies between 1 to 3. So option number 1 is my answer. Now if I want, I can also check my answer. So I know that the first number is 3. So I raise 3 to the power 1, 4 to the power 2 and 5 to the power 3, and I get 144, which is indeed a perfect square, and its square root gives me 12, which is also the sum of 3, 4 and 5. Because I know the square root should be equal to the sum of the 3 integers as per the question. So 12 is equal to 3, 4 and 5. So it becomes option number 1. Now, if you look at the methodology, it seems pretty simple, may not be so simple in the environment of an exam. Okay, so we'll see if we can do something with the options. Okay, can we try to solve this question somehow using options? So my advice to you is that if you read a question and if you don't get any idea how to proceed, so what you should do is you should take baby steps. When I say take baby steps, in the sense, you take one example and see what happens. So say I will assume the value of m to be something. For example, say the value of m is 1. And you proceed with the question and see what you get. Does it satisfy the condition or not? So when you take this example, it also helps you clarify the question properly. It helps you get clarity on the question, and it might also give you some idea how you can solve the question. So always whenever you are stuck with the question and you don't know how to proceed, I would suggest take a simple example and see what you get. If you are fortunate enough, with that example itself you might get an answer. And if you are not so fortunate enough, at least you will get more clarity on the question and you will understand, maybe you will understand how you can try to solve the question. Okay, again here the options are small, so let me try some value. So let me try 1. So since 1 is the smallest number, so the 3 numbers will be 1, 2 and 3. So I raise 1 to the power 1, 2 to the power 2 and 3 cube, which gives me 14, which is not a perfect square. So there itself I can say that 1, 2 and 3 cannot be my answer, or m equals to 1 cannot be my answer. I can straight away say that. So like this, if you try some options, it takes what? Like less than 10 seconds to try an option, and maybe if you try some 5-6 values, you may get your answer. So if I try 5-6 values and if it takes 60 seconds, that is a minute, by options itself I can get my answer. Okay, so this cannot be my answer. I know m equals to 1 cannot be the starting number, but still let me take the square root and see if it can give me some idea. So looking at the square root of 14, it might give me some idea that which are the values I should be trying. Okay, so if I look at the square root of 14, square root of 14 is approximately 3.7. Now you need not know this value exactly. Anyway, this is not my answer. So you need not know this value exactly, that what is the square root of 14. So I know the square root of 14 will lie somewhere between 3 and 4, because I know 3 square is 9, 4 square is 16, and it will be closer to 4. So I will assume the value of square root of 14 to be 3.7. Now, if indeed my numbers were 1, 2 and 3, then the square root of 14 should have been equal to the sum of the 3 numbers 1, 2 and 3. But that is not the case, right? Obviously, this is as expected. I mean, we already saw that 14 is not a perfect square. So obviously, you will not expect the square root of 14 to be equal to the sum of the 3 numbers. But what I am trying to tell you here is, can I see a comparison? 3.7, the square root is less than the sum, right? 3.7 is less than the sum. So as I increase the value, say for example from 1, if I go to 2, I took the smallest number as 1, so my 3 numbers became 1, 2 and 3. Now instead of 1, if I take the smallest number to be 2, so my 3 numbers will be 2, 3 and 4. Now I will be applying a cube on 4, and if I apply a cube on 4, so 4 cube will increase quite rapidly, and thus the square root will also increase quite rapidly. But the sum of the numbers need not increase so rapidly. So it tells me that as I increase the value, the square root should increase, and at some point it will become equal to the sum. So let me try a higher value. So maybe let me try 4. Let me start with 4. So if I take 4, if 4 is the smallest number, so my equation will be something like 4 to the power 1 plus 5 square plus 6 cube, which gives me 245, which is again not a perfect square. Again, I know 245 cannot be my answer, but let me see what kind of square root it gives me. It gives me 15.6 approximately. Again, I know 15 square is 225, 16 square is 256. So since 245 lies between 225 and 256, so my square root will lie somewhere between 15 and 16. So say it is 15.6. Okay, again it will be closer to 16. So say it is 15.6. So again, 4 cannot be my first number, but the important point here is, if you look at the sum of the three numbers 4, 5 and 6, it comes out to be 15. So now my square root is greater than the sum. If you see earlier, when I took m equals 1, my square root was less than the sum. Now my square root has become greater than the sum. So somewhere there has been a transition. The square root being lesser than the sum. As I have increased the values, somewhere the square root must have exceeded the sum of the three numbers. So I know my first number has to be less than 4. And I can conveniently mark option number 1. Because as I go beyond 4, the cube term will increase drastically. And thus the square root will also be quite high. And it will always be greater than the sum. So, just trying 1 and 4 tells me that my answer should lie between the first option. And if you want to confirm, you can just try some values. So, if I take, say the m value equals 2, then my sum will be 2 to the power 1, 3 square plus 4 cube, which will give me 2 plus 9 plus 64. 64 plus 9 is 73, 73 plus 2 is 75. Again, it is not a perfect square. So 2 cannot be the smallest number. Let me try 3. 3 to the power 1 plus 4 square plus 5 cube. 3 to the power 1 will give me 3, 4 square will give me 16, 5 cube will give me 125. If I add these 3, I get 144, which is a perfect square. So let me just check if the sum equals the square root of 144. So sum of 3, 4 and 5 is 12 and the square root of 144 is also 12. So all the conditions get satisfied. So 3 has to be my first number. So I can mark option number 1. So what I am trying to show you is, even if you are not able to generate a complex situation or a complex equation, you can still try to use options to get an idea and solve the question. Always keep an eye on the options, and most of the times the options will show you the right way. If you have any questions, please post them below and I try to answer them as soon as possible. Thank you.